Okay, I wanted to help you with this mini project from Monday's homework. I was due the 24th as part C, creating this graphing calculator file. So the point of this is to graph. We could set these parameters here in the first two lines, and it will graph any piecewise function according to those parameters just by hitting graph. So we'll start it together here. So everyone's going to have in their first line, you'll have this line here. So either we're going to be over here in graphing calculator, backslash BP1 equals, and I'll just start it at 2, it doesn't matter, then backslash BP2 say equals 5 backslash BP3 equals 8 backslash BP4 equals 15. Okay, so there's our first line. That's the line that's where we can go in and change the breakpoints, make them anything we want. Okay, next line is going to be the rates of change. The first one, so backslash R1, first rate of change, we'll say -2. And then backslash second rate of change, R2, equals 3. So we're setting up our parameters that represent the 4 rates of change. I'll make the third rate 1/2, then R4. So you can do this right along with me. Everyone will have these first 3 lines identical in their file. And so then we're going to graph function, remember control 9 to establish a function. So there's only one more line to put in this file, and that's the line where you're going to define f of x. And it should work such that all you have to do then, after you define f of x, change your breakpoints, change your rates of change, and when you hit graph, it'll give you the new piecewise function. So actually have the function up and running, or have the program up and running over here. And I've actually put in our progressive tax rate function. So I've put in BP1 as 83.75. These are dollar amounts where there's breaks in the tax brackets. 34,000, 82,400, and then 171,850. Remember the first $8,375 are taxed at 10%. Then the next bracket is taxed at 15%. Then up to that is taxed at 25%. Then up to that 28%. And you see that when I get the scales right, I zoomed out, there's our tax due function. As we know, that's a piecewise function. Okay, or I could come in here and we could recreate the basketball rocket function. So the first breakpoint, the breakpoints for every half a second. So I go 0.05, 0.05, 5. So every half second was we know the rate of change was boosted up. The first rate of change was 0. And then every half second it jumped up 1 foot per second. So this is just the first, the breakpoint. So first breakpoint's at 0.5, second breakpoint's at 1, then 1.5, then 2. So this would be the basketball rocket function for the first 2 seconds. Of course you can't see this because now I've had this set up for the tax functions. We're going to have to zoom way in. And this should start to appear here. Okay? And so that's the first 2 seconds of the basketball function. So notice, so I have this, your job is to come up with that last line, which is underneath the, behind the curtain here. The last line is fx, which is piecewise definition that works by, all you have to do is change the parameters, different breakpoints. Here's breakpoint 1 is a half second, then 1 second, then 1.5, then 2 seconds. Define the rates of change you want in each. So I wanted 0 for the first half, then 1, then 2, then 3. And then all you have to do is hit graph, and it'll give you the piecewise function defined by those 8 parameters. Okay, so in what you will email me, we'll have these 3 lines, and then you have one more line that enables this function to this file to work the way it does. Just change the parameters, and it gives you the piecewise function of 4 pieces. Okay, I hope that helps.